The situation we're going to talk about now doesn't seem to have very much to do with dogs, but actually it has everything to do with the physics that we use in analyzing the previously mentioned situation. Okay, I've got here a screwdriver. I'm not going to mention the brand name. These things don't have a lot of energy. They don't exert a lot of torque, and they don't work all that well, but for small jobs they can be real handy. If I want to drill this 1-inch sheetrock screw into this piece of oak plywood, let's see what happens. Okay, it's going in just fine. Okay, let's see. We can see what the, wait, now, slowing down. And it just about stops. Now, there are a couple of questions we can ask. Why does the thing slow down? Well, a lot of the answers have to do with an understanding of electricity, and that's not something we talk about first semester, although second semester we certainly do. But why does it slow down? Well, obviously the screw gets harder to turn. This thing has limitations. Another question, how much energy does this thing use in driving that screw? How many screws could I drive? How much energy would I use up out of this battery? This battery has a limited amount of energy. It'll drive a limited number of screws. Another question, what if I just drove the screws halfway? Does it take only half as much energy to drive the screw halfway, or does it take more than half or less than half? You might consider the fact that the second half is harder to drive than the first. Does that really take more energy? Okay, so we have questions about work and energy, also about torques, okay, about the rotational forces that I'm able to exert with this thing. Also, what about backing the screw out? Does that take more or less energy? So energy is an important concept in physics. There's just one example. And the thing that ties this example together with the other is when I was swinging a club or a rod, I was essentially rotating at about some center of mass. And there's a rotation involved here. And we end up having to study rotations and rotational effects and rotational forces, or called torques. Okay? Physics applies to the motion of a car. When I drive my car, if I accelerate from rest up to 70 miles an hour, it takes a certain amount of energy to do that. And that amount of energy can be very well defined. We can actually make very good estimates of how much energy it takes to do that, as opposed to driving down the road. For example, if I drove for an hour, accelerating to 70 miles an hour, then braking to stop, then accelerating to 70 and braking to stop, accelerate to 70, brake to stop, how much energy would I use, given a knowledge of exactly what my velocities are at different times, or at least how long it takes me to accelerate to 70 miles an hour. Whereas I'm driving down the road, how much energy does that take? And the amount of energy that it takes is going to be related to how much gasoline it takes, because the energy comes from the gasoline. Now, of course, the gasoline goes through an internal combustion engine, and there's this science called thermodynamics, or a branch of physics called thermodynamics, again, that we don't study first semester, but we lay the foundations so that we can study it effectively second semester. So what goes on in that situation? What goes on in that system? How do we get the energy ideas? With a car, again, what happens to us as we accelerate? We hit the accelerator, we feel like we're pushed back in the seat. What's going on there? Why does that happen? We're driving along, we hit a concrete wall. Hopefully we've got airbags and seat belts and nothing bad happens to us, but it's going to be rough on the car. What happens in that collision? Why does the airbag protect us? Why do the seat belts protect us? What happens when we go around a curve? You know, we feel like we're moved toward the outside of the car. What's going on there? Why does that happen? How can we explain that in terms of physics? So there are a lot of things that we can talk about involved with the motion of a car. You see me keep looking off to my side. I've got the monitor over there and my notes over here. It's not that I'm being distracted by mice or anything of that nature, but I can't keep all my thoughts together. Okay, we'll continue in the next clip.